Okay. So let's talk about an object, but now instead of just allocating a certain number of them, R of them, to an on or an off, or white or black, right? Or a yes or a no, right? If it's multinomial, you can allocate different quantities of the total of n objects to different tasks, right? More than two. So, but now we can allocate different quantities of n to more than just, say, two tasks. Or binomial, i.e. choose or not choose, or on or off, etc. Right? So let's say you start out with an object, right? So anyway, we can say let A, B, C, D represent different tasks or options or allocations, etc., to which, actually, hang on, let A, B, C, D represent the quantities of n. I mean, I like that, but not. Let A, B, C, D represent the quantities of n allocated to the multinomial, or the many, i.e. more than two. It'll make sense as we get into tasks or options or allocations, etc. A, B, C, D that represent the quantities of n allocated to the many tasks or options, allocations. So, let's say, for example, you start out with n objects, right? Let's say first, let's talk about the tasks or the options as A, B, C, D. Option 1, op 2, op 3, op 4. So you may decide, so let's say n is 5,000 things, okay? You may decide that you want to take A of those n things and paint them white, right? So the question becomes, now the objects are different, okay? So n unique objects. So the question becomes, how many ways can you take A of those n objects, right? And, I don't know, paint them white. Agreed? Let's say there were 10 objects. let's say you were to take 3, it would be 10 choose 3. It doesn't matter, you don't care about the order in which you select 3 from the 10, you just care about which 3 of the 10 you're going to paint white. You with me? So A would be like the 3 that you would take, and N would be the 10, or the total. Agreed? Now once you've selected 3 of the total of 10, how many are left? 7. Or more generally, N minus 8. Yeah. So this is the total amount, this was the total quantity of objects you started with. You took A of them and you dumped them to option 1. Okay? Now there are N minus A left. And you're going to take B of them and dump them to option
B or 2.
2. Maybe that means painting them green. Agreed? Now how many objects do you have left?
N minus 2.
And you're going to take C of them and paint them whatever, pink. And so on and so forth. Can we make a final statement? I guess ultimately in the end, our last choice is going to consume everything that's left. I'm not sure how to write that in a general statement, but that last letter is going to eat up everything that's left, right? Because you're talking about the possibility of choosing all of it, right? So how could we do that?
You say N minus bracket A to dot, right?
N minus A minus B minus dot, minus, well the thing is there has to be something left, right? So I get, oh, I'm so silly. The last letter, let's call the last letter something. What might we call the last letter? Let's give it a general.
Something is more than 26.
Yeah, let's give some, we'll give it a letter. You want to go
M. Alpha.
M, you want to go with M? But I don't know why, for some reason I feel like
M.
Oh,
There's probably a
I like Greek. I like going to a different language.
Alpha.
Segev.
Different.
Okay, let's go with alpha. Let's go with alpha. I like alpha.
Third.
The bottom line is that you're going to have alpha left, and how many are you going to take?
Alpha.
Alpha, right? You got to use them all up. Make sense? Now, let's see if we kind of, you remember the definition of combinations, the mathematical definition? It was basically it was permutations with order removed, right? So permutations was n factorial divided by n minus r factorial, the number that aren't in the lineup, if you will. Combinations was that divided by r factorial, again, to remove the order. So if we apply that definition here, we have n factorial over n minus a factorial. Do you agree with that so far?
Yeah.
And then over here we have, that's not cross product, okay? It just means multiplication. And then over here, you guys do the expansion. You guys do it. You don't need me. You guys, I'll write it up afterwards. Let's see what happens. Does anybody want to come in? I'll fill it in a sec, but let's see. You guys fill it out. See if there's anything interesting that happens. Fill it out and see what you get. See if anything can work together. You don't need me at this point.
So if we get
You want to extend?
I want you to do whatever you want to do. Do you see anything happening yet? Anything nice?
Yeah, it's close together.
give it first one here, 3 up, and then one down.
n minus a minus b minus c plus z is
And then the last one is going to be 1.
So did anybody get stuff like that? Wally, no, you don't follow?
So yeah.
Yeah. So check out these two. And then check out these two. Then I guess ultimately what's going to happen down the line is this guy's going to go with whatever lives over there, right?
Yep.
Not that it really matters, because guess what this equals anyways?
1.
But that's okay. It's going to cancel out with something down there. Now what you see is that this thing could be rewritten as n factorial over a factorial, b factorial, c factorial, dot, 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 all the way to alpha factorial. And see if we can introduce some more notation. You guys, have I shown you guys what sigma notation is? Like if I write down I, okay, that's sigma. I don't know Greek, but I think that's capital, let's say, and that's lowercase sigma. So if I write something like this, who knows what that means? That means x plus x plus x plus dot 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 plus x n times. And who has seen a notation like this? Wait, did I write? No, there's no equal sign here. This is just like this, x sub I. Okay, where this is,
One, two,
and I don't think I need to write the n times here because that's obvious, it's there in the subscript. Do you guys follow that? This means, replace this with 1, take the first value of x, and this means, this is the add feature. This means add. And add to it Rolodex to the second value of x, and add to that the third, and keep going until you hit the final value of x, which would be the nth value of x. Well, mathematicians also wanted to create a notation for multiplication. They use pi, and so you would have a scenario like this: x1, x2, x3.
so you're going to say xi.
Sorry?
After the sign, you're going to say xi.
Oh yeah, that's right. Thank you. Yeah. So I guess we could do something like that. We could leave this like this, or we could write it as n factorial I. I guess we're going to go from I equals a to alpha of x sub I.
And I of
But it's going to be x sub I factorial.
then it's going to be xa factorial.
The only thing is, I think it's got to be I.
Yeah,
You're just going to make this I like that. And then you replace I with an A factorial, and then a B, and then a C, and so on and so forth. So, did anybody find that when they were looking last night? No? Who saw it?
Yeah, but I didn't know what it was.
Another way people write it sometimes is like this. You'll see n, a, comma, b, comma, c, comma, dot, 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 let's say comma alpha. Okay. Meaning, the n choose a times the n choose b, times the n minus a choose b, and so on and so forth. But it's another shorthand for this. And I guess you could further rewrite that shorthand and using that as n choose I equals a to alpha of I factorial.
No factors.
Yeah, we need a factorial. All right, because we could put a. Hang on, do I have multiplication here? I don't like this. I don't like this one. I don't like this one. Let's leave that up. Let's do that like that. Let's do that. So this is more powerful than just Pascal's triangle, right? So the textbook only shows you Pascal's triangle, right? But if you think of Pascal's triangle, as I said, as a binary triangle, right? And then you think more generally, you can think of a multinomial situation, right? Because sometimes you don't want to just have things on or off. You may want to have more options, right? And then you see that you can generate a more general formula like this. Again, now you could take, for example, that more general, more powerful general thought and apply it to, you could apply it to binomial again. And do you get the same thing? Well, again, if you have an object, so let's say you can have yes or no, you can say, okay, well, I have n objects. I guess you don't even have to, you can do it either way. You can say I have n factorial objects, right? And I suppose you could say, okay, I'll take A of them and make them yes. Let's see what happens. And take B of them.
B is n minus 1.
And make them no. Agreed?
Wait. Why?
B is
Sorry, go ahead.
No, continue. I want to see what happens.
Okay, so you could look at a scenario like that, right? Because that would be a binomial scenario of this, right? This is multinomial. This goes on forever and forever and forever, right? But this takes us back to the scenario before. Now Milad was going to put up his hand, right? Because he's getting annoyed, right? How many think Milad is getting annoyed?
Just see.
I see a lot of heads, but no hands. Smart, right? Okay, go ahead, Milad.
B is the same as n minus a. Because a plus b, whatever is down there, a plus b plus c plus alpha is going to be n.
One thing you'll notice in this scenario is the sum of I equals 1. We'll write it this way first for you guys. A plus b plus c plus dot 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 plus alpha has to equal the total number of objects, right?
So
that's it. Or you can express it another way. You can say from I equals A all the way up to N.
Alpha.
Can you just back the hell off? Milad, you're annoying this morning. What is with you? What's the matter with you? He's so interested, which I appreciate, but he's just, leave me the hell alone. Let me breathe, man. Okay, so we've got I. So we're going to go A and B. Yeah. All the way up to
Oh my God.
all the way up to alpha is going to equal N. Okay, agreed? So the sum of all of these choices equals the total number of objects, because you can't take more than the number of objects that are there. By the way, what if you want to take less than the total number of objects? Can this thinking still work?
Yeah.
Just
Yeah.
change that.
You just have to change the number and the amount that you want to take out.
Go ahead.
You just don't go all the way down, right?
Or perhaps the last letter that you
You
choose
subtract whatever you
would represent the option of not doing anything to the remaining objects. So for example, you could say option 1 is pink, white, option 2 is pink, blue, option 3 is pink, green, and let's say there were 100 objects, and let's say you've chosen 30, 30, and 30, let's say, for the first 3 paints, and now you don't want to paint the last 10 objects. Option 4 might represent not painting the last 10 objects. It actually works quite nicely. But you can't go over, right? You can't choose stuff that doesn't exist. So, we have that. Then go ahead, Milad. Now it's quiet. Unless I scared him.
Go for it.
Let's go!
N minus 1. It's the same as n choose a.
Okay, and so, lo and behold, you get the exact same scenario, whereby A is the quantity, okay, of n that you allocated to yes, right? And B is the quantity of and that you allocated to no, if you will, based on this definition. Of course, you don't see the B in there because the B is really the n minus r. So, are we good with that? So this is actually a specific case of that. More powerful, right? Than just knowing the one case.
Do we actually have questions where this is applied?
But the general one in your textbook?
Yeah, I don't think so.
I don't think there are, but
It's good to have.
especially considering I may ask you questions.
You will have your own test, right?
Can we do
It's gonna be a bonus
I will have
question.
my own test. Who's writing the first test?
No.
Me.
No.
No.
But can we do example with that general?
Sure.
Sir, can we do before the test some examples of what might be on the test?
What have we been doing? What have I been doing?
You haven't been giving us.
Haven't I been taking up tons of questions, making up questions?
Well, yeah,
But you want the exact
No,
ones.
no, no.
Of course you, when you don't say no, yeah. You want the exact ones. Yeah. No. Okay,
That doesn't happen.
let's see, let's take a look at a little bit more of this theory and then let's move on. Mostly, if you can do the questions in the book, that's 98%, 95%, 98% of what you'll see. And then maybe I can get creative like with one question. We've been doing difficult questions too. Okay, so I'm just going to go back because I've been basically doing 4 and 5 in my own kind of order, right?
Yeah.
So 4.1 done in terms of theory, and you've done a lot of questions. 4.2, yeah. 4.3, yeah. 4.4, okay. 4.4.
Yeah, this is the one that I was trying
Okay,
to.
4.4 is really about pattern recognition, and it takes you back to the triangle, okay? It takes you back to the binary triangle or Pascal triangle. Why? Because one of the branches of mathematics that exists involves the recognition of patterns and the ability to not only recognize a pattern, but then create an equation or an expression, recursive or non-recursive. We can discuss that in a second. That's general. What's the value in pattern recognition and being able to create general formulas? Anybody? Yes, do that.
Because you can, after when they ask a question, you can find one of the sentences that are like n the one. If they give you a number, you can find it with the general formula. You can find all the things that you want in that pattern, even though you can't like write it down and get to it.
Excellent. I would say it a little more. I would say it maybe a little more succinctly. Have you guys been taught about the terms interpolation and extrapolation? Interpolate. Okay, if you have a bunch of data points, let's say you were watching a race of 100 meters. I don't know, final. Let's say the slowest runner did it in like 11 seconds. The fastest runner, I don't know, did it in 10 seconds, right? And let's say there were times in between. One person did it the lowest in 10, then 10.2, then 10.4. There was a couple 10.8s and so on, and 11 was the highest, right? Let's say it turned out there was a trend to it. Let's say you actually saw that there was a trend to the quantity of people that ran fastest versus the lowest. Interpolation corresponds to making estimations within the range or the domain, if you will, the boundary. Let's see, because we're not dealing with domain right here. Within the boundary of the data. Extrapolation is about making predictions outside the boundary of the data. So, to succinctly say what Milad was saying, the power of being able to generate a general formula is for the purposes of interpolation and extrapolation, making predictions within the boundary of stuff you already have, as well as outside, beyond, right? If you see a pattern that applies for today, that applied for this week, it would be nice to be able to create an extrapolative pattern that could tell you or predict behavior, let's say, in a couple weeks from now or a month from now, so on and so forth. Make sense?
Thanks.
So that's the power. And then that's the thinking power, but then obviously you get to the notative value. Like you want to be able to come up with a common language. So if Ronald has actually figured out a way of creating a general formula that can be used in the future, he has to communicate that formula. He can do it verbally, but it would be nice if we had shorthand, i.e. stuff like this, so that you could communicate it succinctly on paper as well as just verbally, right? So that's what this one was all about. So let's take a look. This one is good. This chapter is good. I actually like the examples for it. So let's take a look at the first example. We're not going to spend too much time on this stuff, but just a bit.
It starts here.
Okay, so for example, let's take a look at example 4. And we'll come back to this, I'll give you an example for application. Okay, what's example 4?
Okay, so coins can be arranged in the shape of an equilateral triangle as shown. So one is with 1 coin, the other one has 3 coins, and then the other one has 3, 4, 5, 6.
So we have the drawing. So we go like that, right? And then we stack 2 underneath.
Yeah, 2 underneath and 3 on top.
So this is, I don't know why am I shading it?
So why not do it horizontally?
Huh?
Why not do it horizontally?
You want horizontal?
And then it says A. Continue the pattern to determine,
Okay, go ahead.
continue the pattern to determine the number of coins in triangles with 4, 5, and 6 rows.
Okay, so this is,
Was this the quarters question? Is this the ideas question?
Yeah.
so this is row 1, this is 2 rows, this is 3 rows, right? And it asks about the number of coins, right? So how many coins do we have? If we have a 1-row triangle, how many coins do we have?
1,
Then
3.
6,
and
10.
let's do one more.
Do we have to use the T thingy? Visible.
So it seems like the pattern is
Plus the number of, like,
the pattern seems to be
The
1 plus 2 plus 3
plus 4.
Right? You seem to always add.
The number of rows to the.
You seem to always add one. The quantity that you add next always seems to be 1 greater than the
Previous.
yeah.
So the next one's gonna be 15.
Okay, so then what's the next? What's the next portion of that?
15.
No.
Oh.
I mean that's good enough. So what?
Continue the pattern to determine the number of coins in triangles, okay, with 4, 5, and 6 rows.
Oh, they want us to do more. Okay, so then
Yeah,
I'm not going to draw the picture here.
5.
So if we have 10 there, right?
Plus 5.
Instead of adding 4, what are we going to add?
5.
5. So this is going to be 10 plus 5, which is 15, yeah. And then next?
Plus 6.
I'm just going to put a smiley face here and then a frowny face because I can't draw all that. So that was 5, right? And then 6 is going to be 15 plus 6, which is 21, okay.
And now B says locate these numbers in the Pascal's triangle, so.
So let's do that.
The T.
So if we're looking for 1, 3, 6, 10, 21,
Once everything.
we can see, I see a 1, I see a 3, I see a 6, oh, there's a 15 and 21. So I see it running down this way.
Yeah.
Now, I can give you a word of advice. My recommendation is when you see a pattern, okay, recall that moving this way was called rows. So that was row 0, row 1, row 2, row 3, and so on and so forth, right? but positions went on a diagonal from down here to up there. Position 0, 1, 2, 3, so on and so forth. My recommendation is if you see a pattern, go with it this way. Because as you write your formula, notice everything along this diagonal is in position 0, 1, 2. All of these are in R equals 2. Agreed? If you go with the pattern this way, then you got to change the R values. See what I mean?
Yeah.
It's annoying. So might as well go with the version that locks the R value. So I can do this. See, because this is R equals 0. And this is on that diagonal R equals 1. This is R equals 2.
Everything there is
You see that? If you go this way,
1, 2, 3.
it's like this is R equals 0, R equals 1.
You can change all.
This way we can change the n values, but we could keep the R values. You could do it the other way too. It's just annoying. It's just more complicated for no reason. So it's something to keep in mind while you're doing this stuff. If that makes any sense. Okay, so what's the next? It says find them in the triangle. We found them in the
Okay,
triangle.
so now C says, really.
By the way, sorry to interrupt. If you want to do your own thing, by all means, please do your own thing. You do not have to do what we are doing up here. We are moving way too slow. Whatever. Do your own thing. You do not have to follow along. Okay? Do not have to do that. Yeah.
So relate Pascal's triangle to the number of points in a triangle with n rows.
Relate Pascal triangle to the number of
Points in a triangle with n rows.
Well, we can see that when you are in, this is going to be row 0, right?
Always in row 2.
This is n0. This is n2. So everything seems to start here, right? It seems to start in 2, 2. Do you agree that this is term
T, 2, 2.
Yeah.
This is term 2, 2, because the first 2 corresponds to n. That's the way they notate it. And the second one corresponds to r. Notice, this is going to be a constant, right? That's not going to change the way we're going. Okay, yeah, and this that's for a formula?
Yeah, and then D says how many points are in a triangle with 12 rows. So I guess you have to find the formula.
I see, right. Okay. So, we can say number of points. I don't want to use
Row 11.
that.
To T11.
T. Let's write it this way. Triangle. And then let's also say, let's create, I guess, T as a function of n. Does that make sense?
Why?
You guys follow that? So can we create a formula, T, that gives you the total number of points in the triangle, okay? Which is a function of the row number you are in the triangle. Does that make sense? Yes.
Did you just do it logically?
Yeah, but they want it related to the triangle.
Okay.
So just take that logic and then just tweak it.
So can I ask
I
a
mean,
question?
isn't it just like
Okay, where
T11?
n is row number in Pascal's triangle. So what would that be?
Well, n is always 2 in this case, right?
Sorry?
Does it want it in relation to like that?
Yeah, it's always 2.
So it's always going to be 2, and then
And
f
it's
is
plus
just going to be...
N is always going to be 2. So when you're in row 2,
R is always going to be 2.
when you're in row 2, you have how many?
What do you mean by
How many?
N plus
How many
one.
coins? You have 1 coin. See, look. When n, what does this correspond to when you have 1 coin? What row number? Isn't it 2?
Yeah.
Okay. Now, what is r?
The bottom?
Now, when you are in row 3, you have 3, right? And when you are in row 4, you have the 6, right? And so on and so forth. Does that make sense?
But the R stays constant.
And the R stays constant, right? Now the total number of coins is here, right? So creating a relationship between those two is kind of annoying, because here that's going to be 1 less than that, and that's changing that way. But if you use a lowercase t, if you were to use a lowercase t to represent term number, for example, when you are in, just one second, when you are in, just take a second. So when you are in row number 2, right? When you are in row number 2, you have 1 coin, right? So does that make sense? Because if n is 2, you're asking for the number of coins in term 2, 2, which is 1 coin, right? And if n is 3, the total number of coins is going to represent term 3, 2. Term 3, 2 is going to be 3 coins. And then if you wanted, you could simply turn that into, more generally, because recall, each of the values in here, right? This can also be written, for example, as T22, but T22 is also written as n choose r, right? Which is going to be n choose 2 always in our case, right? Because this is never going to change, right? So I suppose we could do that, right? And if we had to define, and I know there's a question behind it, if we had to define n has to be an integer, right? And it's got to be greater or equal to, what's the minimum value of n we're allowing? 1, 2.
I can ask you a question.
One sec, there's another question for you. Tell me if anybody has any issue with this. Does that make any sense? Yes.
So if I now ask like how many coins are gonna be in row 4?
Yeah.
Are you gonna put 4 and stuff now?
Right.
Yeah?
Yeah.
But that's not gonna
That's
give you an
incorrect.
answer.
That's not giving us our answer?
Yeah, you gotta say
When
n
n
plus
is
1.
when n is 4, this is 2, 3, 4. What do we want? 6, right?
But when
Oh, because this is a because it's a physical row?
so n plus 1
Yeah, you're right.
choose
Oh, because these are rows of the actual, these are rows of the physical thing. So these are physical, these are number of rows of coins, right? Good point. So these are the number of rows in the actual triangle. So we're off by 1, right? Here, when you have actually 1 row in the coin, you're corresponding to an n value of 2, agreed? But
n plus
the way I wrote it is correct. Because the way I defined n was I defined n as the number of rows in the triangle. But if you want to do it for, what do you want to call this? Give this a letter.
m.
M?
Alpha.
If you want to do it in terms of m, where m is the number of physical rows in the actual thing, you could say, or t is going to be, well, we have something called the 2, right? Does it give me n plus 1 or n minus 1?
N plus 1.
So when you have 1 physical row, okay, if you add 1 to that, that takes you to a value of 2, which you choose. Okay, I'll agree with that. So n plus 1. But in the end, and that's going to give you m plus 1, choose 2, where m belongs to the set of integers, and the minimum value of m is going to be 1. So m can be, I don't know why they use z for integers, but they do. Greater or equal to 1, and that's it. So if you're defined, I thought the question actually said in terms of the row number.
Of 12. It's just 11. T11.
I don't know what the wording was, but depending on the wording, you could go with this or you could go with
They want to
this.
use the formula you have now to find what the thing will be if it was on the 12th row.
Did it say row of the triangle or row of
I'm pretty sure it
coins?
means row of coins.
Yeah, it says how many points are in a triangle with 12 rows.
Yeah, so
So if you
Oh, I thought when you said triangle, I thought they meant Pascal's triangle.
all you have to do is just make
So,
it.
sir,
Yeah.
the function should be fn instead of f of n.
No, if you're going to write it, in terms of n,
That's
where n is row number in Pascal's triangle, this is fine. If you're going to write it in terms of physical row number of coins, then this is fine. It depends. It's unclear because they're talking about triangle. They're talking about triangle built from coins, but then they talk about Pascal's triangle. They're mixing things up. So,
clear.
It's clear, you just they were just talking about the.
so it doesn't matter. If you just what matters is that you are explicit. What matters is that you are explicit. So you have to define things. Right? I'm fine with either one of those. Yeah.
How about if we would have an example, like one
Wait,
example?
sorry. There was a question here.
Oh, what does R represent?
R represents position on Pascal's triangle. So they call this diagonal position 0, position 1, position 2, position 3.
No, I meant on the graph. Like how come I need all two?
Because everything that exists in this pattern is along this diagonal. And everything in this diagonal is along position 2.
Oh, okay.
So it's not changing. So as you move from here to here to here to here, you are increasing with row number, but your position number is not changing. You see that?
Yeah.
Yes.
What would happen, for example, if we wouldn't have a pattern so precise, right? If we would have one on one and then the other. For example, like one example that I found
We can look at examples, yeah.
was number 13 on page 252.
Okay.
Number 13. Which page? Which page?
Number 252, the page, and number 13.
252.
A straight line drawn through circle divided into two regions. Determine the maximum number of regions formed by any straight line. So what I recommend we can do is we can try this question as well. Let's read the question, see if it makes sense to you. The idea is that you start with a circle, and then if and they're defining, see, I don't like the letters they use because they're going to use n for lines, but
What?
we also use n for right, whatever. That's what I'm saying. I'm allowing for a certain flexibility as long as you define what it is you're doing. So they're talking about a circle, I guess, right? So when n is 0, meaning you have no lines, you have one region inside the circle, and then if n is equal to 1, you cut the line in half, you have 2 if n is equal to 3. Does it say how the 3 lines have to go?
No.
It's just a peace sign.
Oh, but it can differ.
Do they have to? Because might you not get a different answer depending on how you use 3 lines? Does it say they have to touch the?
No.
If they touch
You
one,
do
you
get-
get
You still get the same answer?
Is it this one?
So if you go like this,
You don't get the same.
You don't get the same.
if I go this way, right?
You
I
don't.
get 1, 2, 3, 4, 5, 6. And if I go this way, for example, I don't know. I get 1, 2, 3, 4, 5. So
Yeah,
you
that's
don't
how
get
it gives it.
Yeah,
No,
there's a picture here.
Yeah, there's a
That's not-
picture. It's,
They're not. They're not
they're not making it
They're not
hit the center.
doing it at the same point.
Yeah.
So we're going to assume that for the
Yeah, that's what I
continuation?
didn't get. Like, do you have?
Where do the lines
Do we?
go?
Yeah, that's how.
Yeah, because there are
that's
different
how-
possibilities, right?
Then you just.
I'm wondering, like, what happens if I go with another one now?
Because how I did,
The
I
answer
go
would
with
be
the first
different.
one.
So is the idea that we're going to never touch any intersections?
That's how the
Is that
picture
what-
says.
You're
it?
missing one line right now.
Sure.
You're missing one
You're missing
horizontal
this
line.
one here.
What do you mean? I'm just starting from the beginning. I just start. There's no lines, there's one line, there's
Two.
2 lines, there's 3 lines, I don't know, there's 4 lines. Like they want a general pattern, right?
Yeah.
Each time you create a line, they want you to count the number of pieces inside. But I'm just saying that, just thinking aloud, I get a different tally if I cross over like those pinch points, Alexei and Kenya.
Well, since they're saying the maximum amount of regions.
Oh, does it say the maximum number?
So I'm
Oh,
pretty sure
beautiful.
you go through each region.
Yeah, beautiful, maximum number. So you can clearly see that you have,
So you
To
should
get maximum, you have to go through each region every time. I mean, not each, like, first time you go through 2 regions, second time you go through 4 regions, third time you go through 8 regions.
I don't follow you.
but I know that here I've counted a total of 6, right? And here I counted only a total of 5. So based on what you were
Or
saying,
take the 6.
let me,
No, sir, that's.
you lied, you were very annoying. Like, I'm not gonna answer you when you just talk out loud. It's really annoying because what happens is, it's a conversation between you and me. And it's not about you and me, it's about all those people. But why are you so interested? Why are you so interested? Why don't you just do your own thing?
I just like the subject.
Okay, that's good, but you gotta wait.
You go.
Okay, a straight line drawn through a circle divides it into 2 regions. Okay. So then, yeah, determine the maximum number of regions formed by n straight lines drawn through a circle. So then, Alexei, based on that, when I'm drawing the 3 straight lines, wouldn't it be, based on what they're saying, would it make sense to do the picture on the left?
But you,
If it's
why?
maximum.
At least in the left has
Left, yeah.
You're making 6 regions that way, whereas if you cut across, let's say, across like that just below the center, you're cutting into how many regions? Like
Isn't
1,
it
2,
less?
3, 4, 5, 6, 8.
Some more?
Yeah, 7.
Oh, you did 8.
Yeah, so you're cutting into 7.
Sorry.
So it's,
So you're saying
So
do
if you-
this, and then cut
below,
this way?
yeah, then you make 7 regions.
Yeah, 1, 2, 3, 4, 5, 6. Ah, okay. All right. Right. Sorry, that wasn't the max. So that was the max, right? Because in this case, I touched here on the outer edge. So you're saying that you want to keep everything, and you want to keep all intersections on the inside, and you want to maximize at dual intersections. Do you think that will do it?
But I don't know if there's like a pattern to how you can.
I don't know. But we can do a bit. We can see what happens. Okay, so whenever you do it, I guess you're doing it in such a way that you cut in such a way that you maximize the number of sectors that you generate. So you guys can try it, and I can try it too, I guess. So this is a drawing. And n is the number of lines, right? And then S is going to be number of sectors. Sectors, I guess, that you get. 0, 1. I'm going to run it. I'm going to keep drawing so big. So we have 1, 2. So we're not going to do that, right? But we have to, at some point, we're going to have to cross it. I don't think there's any other way. You go through that way. Doesn't matter, you have to intersect with them. Some. And then using the Alexei's logic, we'll go like that.
I think the pattern is that every additional line, you can cut 1 plus 1 more sector. Like,
With every additional line, you create 1 more sector?
no, you can cut through an additional sector. So let's say in the first one you can cut through 1 sector. In the second one you can cut through 2 sectors by adding a line. In the third one you can cut through 3 sectors. And then
And when you cut through that sector, are you saying you double its size?
I'm not saying how many you get, but I know
see what you mean, yeah.
every additional
Yeah,
line,
Sure, here you've cut through 1 sector,
2
here you've
sectors.
cut through that sector and that sector.
And then I just did the 4th circle, you can cut through 4 sectors.
Okay, so how many,
Oh,
So that's 8.
how many do we have here?
8. No, 7.
That's 7.
I count 7. There's a
Seven.
little baby one there, 1, 2, 3,
7.
4. So that's how many? 3? 1, 2, 3.
Get 2 and 2
7.
7.
3 and 6. Why not?
I don't even know.
You depend on the last
But I don't know if that's actually true, it's just from trial and error.
If you want to find free
And what effect does it have on the,
It'll still be this.
You have to find a line
You
that
draw the other
crosses
side
the
there.
most.
And then you can cut through 4 sectors by going
so we
like,
want to cut through as many sectors as possible, is what you're saying, in order to maximize things.
and I think that one is, you can only cut through 4 maximum.
C, 1, 2, 3 there. Where's the 4?
If you cut across like this, like that,
This way?
yeah, so you go through the
Here?
bottom of that, you go to the next one, then to the top of
This
the-
one?
Yeah,
So 1, 2, 3, 4, that
yeah,
way?
like that.
Something like that? Okay, so I agree with. Ah! Yes?
Yeah.
Yeah.
Okay, so we're gonna say pattern objective or pattern building objective is
And actually what you get is,
let me just write this first. When you're saying the first thing you said, when adding lines, do so a way to cut across as many sectors as possible, right? Possible.
I'm pretty
To
sure.
maximize number of new sectors generated. Yeah, go ahead.
I think it's going up by 1, then 2, then 3, then 4, then 5.
So if you count here,
You should get 10.
you're saying we should end up with, this is a difference of 3.
Yeah, so plus 2, plus 3, then 11.
So
So with that logic, it's like
Except
I don't want to draw the last one. Does anybody want the next one? Does
So it's
anybody?
plus
16 is the next one.
Does it
Yeah.
work?
Yeah, it works.
And at 15, you
'Cause it's
should.
like, yeah, because you add 1, 2,
And just tell him what the
3.
15th one is. Or
So now
does he want the 15th?
I don't erase this, right? Just because we're referencing it. So if we actually look at our pattern based on what you guys are saying,
If you hit the 50 and make it 15.
what are the numbers wrong? 1, 2,
4, 7, 11, 16 plus 16 plus 6,
22.
22.
okay.
After 15, you should have 121. Is what I arrived.
So the delta here is 1, and the delta here is 2, and the delta here is 3, and the delta here is
Just a
4,
second.
It's the edge of the-
and the delta here is 5. Delta just means difference, right?
Yeah.
If you
So the first difference is 1, and then the second difference is 2, and then so on and so forth. Okay, and what are they asking us to do?
find the 15th one,
Oh, find the 15th one.
and then should I tell you?
Okay, so now we want to know the quantity of sectors, right? So we are talking about S, right? So before you tell us the 15th one, Ronald, can you generate
A formula?
a general formula where S, which is going to be the number of sectors, is going to be a function of N, the number of lines?
And okay,
You know what I mean?
like before what you did with the other thing.
It doesn't say the triangle this time, right? Don't have to use the
Yeah,
triangle.
it says use a Pascal's triangle to develop a
It
formula.
says that?
Yeah.
Yeah.
Oh yeah, 3A says
Yeah,
that.
Yeah, that's why I
Who puts
asked
the
you,
button for
there's
us?
no actual.
Yeah, it's in the triangle, but again, I want to be, determine the maximum number of regions formed by n straight lines. What is the maximum number? Describe how you would set up a
Is it in the row? Is it
number of regions inside a circle cut by 15. Maximum number of regions. Oh, okay. Determine the maximum number of regions formed by n straight lines drawn through a circle. Use Pascal's triangle. Okay, so I want two. First, I want you to give me this formula, right? This is not with the triangle. Okay, you with me?
Can I just put something else?
I want you to give me that first.
It'll
Can
help-
give me
it'll
that
help-
first.
it'll-
It's n plus f of n minus 1.
N plus f of n minus 1.
That's not the general formula.
So you're saying n plus f of n minus 1?
Yeah.
Is that what you're saying?
Yeah.
Why? Let's see if that works. Now that's what's called a recursive formula, by the way. So in other words, in a recursive formula, you always need to know the previous value, right? That would be, so that's called a recursive formula. A formula that's non-recursive is actually more powerful because you don't need to always keep calculating the one before. But let's say that one even works. So you're saying that when, what was n? N is the number of sticks. So let's just test it. If you have, here, this is n equals, so this is s, right?
Those are the sectors, yeah.
And this corresponds to n equals 0, right? 1,
2,
2, 3, 4, and 5. So when n is, let's say, 3, let's see what happens based on this formula. You put in a 3, and then you evaluate the function at f of 2, which would have been 4, which is 7. Does that work?
That did work.
That works, right? Okay. So this is there's nothing wrong with this formula as far as I see. So this is correct. And this is what's called a recursive formula.
What's the general formula?
Okay? No, this is a general formula, but it's called a recursive formula. In other words, in order to get an answer, you have to look at the previous answer, right? That's what recursive formulas are in general. You always need to know what came before, if not immediately, maybe a couple of terms before, okay, in order to get an answer, but they are valid formulas. But if you guys could generate I love this is really good, Wally, because I want both. Now, if you could generate a non-recursive one, that would be more powerful. In other words, one that's a function of n, whereby I don't actually have to figure out
The
previous, right? And you could have written this as f of n minus 1 or s of n minus 1. This is perfect. Yeah. Can somebody give me a...
I want to ask a question. So basically to find these formulas, we just need to do a lot of trial and error, right? So
Pattern recognition, trial and error. You can call it pattern recognition, you can call it trial and error, whatever you want to call it. Yes.
I just point out something.
Before the pointing out, I want the answer.
It'll help us find the answer.
Question.
But maybe there's somebody who has the answer.
Who has the answer?
Question.
No.
Can somebody do a general one?
I'm trying to.
yeah.
We're not allowed to use sigma.
Why not? What did I say? You can't use that.
Can you use sigma?
Why not? No, is there? Yes. Okay, go
I can put my thing
ahead.
up.
So nobody has an answer to that?
If you follow down row 1, it is our like pattern, but it like follows how we skip numbers. So it goes 1, 2, and it skips 3, and goes to 4, and then you skip 2 after that, 5 and 6, and
Yeah.
goes to 7. And then after skip 7, it'll skip 8, 9, and 10, go to 11.
Yeah.
It follows the chart in its own way. So
So you can take points
can
of
take-
it and then.
So, okay, but
I found it all myself.
so what you're
Well,
saying to me,
averages.
oh sorry, what you're doing is,
There's a T chart. The T chart's
So
represented in the
T,
triangle.
1, 1.
Is what I'm saying.
so you're going back to the actual Pascal's triangle.
I just realized it's the same thing.
Sir,
Yes.
the answer is in the back of the book.
Don't do it.
But like you wanted the answer, didn't you?
I suppose. I mean, I suppose I could try and do all this stuff for you guys too, but then like you wouldn't learn anything. Okay, so you have an answer to that. Don't keep it to yourself.
Yeah,
Okay, I think what you're getting at is you want to give me an answer based on the triangle. You want to go
I
straight
think
to
it's
the triangle.
easier to do
It's
that.
easier.
You think it's easier. Okay, so let's take a look at your answer. So what are you suggesting? You see 1, 2, 4, 7, 11, 16. Show me those in the triangle, sir.
Can I stand up?
Yeah, you can go over there.
How do I?
Just hop over.
You just hop over? What the T chart represents is like this, right? 1 is
The what chart?
the zeroth
The
row.
what chart?
The T. Okay, what I did was like that, and then N,
Okay, yeah.
and S, blah, blah, blah. So it represents 1 here with the row. Like the first one we have is 1 because that's like the circle.
You're not talking to me, right? I know what you're doing.
Oh, you know what I'm
You
doing?
want to talk to
I
them.
think the class understands, right? remember this? How like we have all the points we have, like 1's here, 2's here, 4's here, 7's here, and then we skipped 1 here, we skipped 2 here. So the next term we can skip 3, and then we'd arrive at 11.
So then just put the points so that maybe.
And then
we
it'd
can
go
draw.
like downwards. So I don't know. Like
Like
if
put
you
the
visualize it
points
this
one
way,
by
then you can find.
You can lock the R's in at 1.
You can lock the R.
Well, look, what position are you in?
I'm in position. What do you mean position?
Yeah, R is 1.
R
You're
is
in
one.
position 1, so 1 does not change.
The diagonal.
Oh.
So that's good.
So we're locked here. And then,
Circle R equals 1, so that they. No.
and then the one
That's not what I
thing is
meant.
N.
The whole diagonal.
Oh, you want me to do like that?
Right. Oh boy.
Pascal.
That's R equals 1. So by doing it that way, as opposed to going that way, as opposed to going that
Because
way,
then
you don't have to
this is locked
change.
in,
You don't have to change
the
R.
R.
And now you got to find a way to indicate what you're saying.
I don't know how.
So I just realized the Pascal triangle is.
Did you put up your hand?
Sorry.
Yes. You can do that, Milan. Look, he can do it. You can do it too. Yeah.
Can I submit a sigma solution?
Please, come on up. Go ahead. I like how you guys are
So
going.
we locked the 1, but now we just. need to
I don't know what to do after
number.
that.
The locking of the one is the easiest part. I'll let you guys. Oh, that's not trying to say sigma. It's got like little
curve.
like it's got a hairdo and. What's on the left? Where's the equation?
Oh.
Is it S equals? Is that what you're saying?
Yeah.
Just write down S equals. It's easier for everybody. Okay, let's see. And circle it because we have a messy board. It's fine. It doesn't have to be perfect. Yes. Okay. Well, let's take a look at this fancy thing here. And N is, what does N represent? Is N number, this is why these questions are stupid. Is N number of lines or is it the row number in the triangle? Number of lines.
Yeah, so you can start at 0.
Okay. So let's take a look. You guys take a look at what he's saying. You guys sit with it and see if you agree with it or not. I'm going to look at it too. Of course. Oh, let me see.
Says it works.
You need me to tell you that?
I think it works.
Test it.
Yeah, it works.
You test it, and then you think about it, and then you put up your hand if you think it works. Take a look at the deltas that we talked about. The deltas were 1, 2, 3, 4, 5, right? So the differential, in each case, you're adding the differential to the previous value. Agreed? With the starting point of 1. So if you think about it, I almost visualize the formula the exact same way, just in reverse with the 1 plus. I kind of visualize it this way. 1 plus I equals 0 the end. Sorry, let's make it fancy like yours. Mine will have some hair too. Alright. If 1 is my starting point, the first delta that I want to add to that 1 to get to is a delta of 1. So, when you let I equal 0, okay? Rather, first, I apologize. First things first. First, you have to get the first term. So if you're starting at 1 and you want to keep 1 that way, you want to add a delta of 0, right? You don't want to change that value. So if you start with 1, you want to add 0. And if you take a look at this formula, that works, because when you replace I with 0, 1 plus 0 gives you back 1, right? But then, of course, that result of 1 has to be added to a delta of 1. And then when you replace I with 1, what does your delta become? 1. 1 plus your delta gives you 2, right? And then at your next stage, your thing is going to go up by another value, right? Okay, it's going to go up by 1 again, right? Okay, in actuality, in this case, n is 1, right? So we had a 0, we had a 1. In the next case, n becomes 2. But when you put these together, what does your delta become there? What's 1 and 2? 3. 1 plus a delta of 3 gives you 4, right? So I would say that this is excellent, as we said. And this is also excellent, and this is non-recursive. Now, which is more powerful, the recursive or the non-recursive?
Non-recursive.
By the way, we're learning chapter 1 at the same time, you don't realize. The non-recursive is obviously more powerful. Why is the non-recursive more powerful?
You don't need the previous
Put up your
term.
hand. Yes.
You don't need to know the previous term.
Yeah, you don't need to know the previous term or previous terms. You just plop it in, right? So this is excellent. I love it. This is a great lesson here because you guys are generating everything. And my last thing would be, Alexei, could we then? I hate this stupid fact that they use n's. So what are we gonna? If they've used up n to represent number of sticks, does it work with like let's let I don't know, we're gonna row number, I don't know, we'll call it let G be defined as row number in Pascal's triangle. Alexei, is there a way you could take your formula and make an adjustment to that so that we could replace n with its equivalent in terms of G? That is to say, how would n and G relate? If G represents row number in the triangle, you're starting with an n value of 0, right?
Replace what?
Is there a way of doing that? It's tricky. But, yeah.
But what do you want the outcome?
To get the same outcome of S, right? But instead of your function having an n here, is there a way to do it whereby instead of it being n, it's G? So you enter row number of the triangle and it gives it to you.
Oh, instead of the...
You know what I mean?
Yes, instead of...
I mean, I'm perfectly fine with this, but I'm just curious. Yes, Mila?
So I'm not trying to answer your question.